Let's say now we have given this equation y is equal to 5x plus 1, and then we divide that by x squared plus 5x plus 6. Guys, please close your mic if you are not asking a question, right? So now from here, what we're going to be doing is that we know that when we want the domain, we actually want where the function is undefined. So you can actually say x squared plus 5x and then plus 6 must not be equal to 0. So why do we say x squared plus 5x plus 6 must not be equal to 0? Is because we do not want the denominator to be 0, because once we say 5x plus 1 divided by 0, then this will be undefined. So there will be no solution for this. So hence now we're saying that we must not have 0. But if we are having a negative number, let's say negative 5, or maybe a negative 1, whatever, we'll still get a solution. So now we don't want 0 there. So now to do that, now we can actually factorize that equation. I believe everyone is able to factorize. So that must not be equal to 0. And then the factors of 6. What are the factors of 6 that will give us 5 when we add, and then when we multiply they give us 6? I think it's 3 and 2, right? So they are both positive. So now we can say that x plus 3 must not be equal to 0, or x plus 2 must not be equal to 0. From here we have x must not be equal to negative 3, or x must not be equal to negative 2. So those are actually our restriction. So from here, what we have to do always, in order for you to get this thing correct, you must be able to draw a number line. So if you draw a number line, this is how I actually draw it. So I put those points that I got there. So I have negative 3, which is lesser than negative 2. And then this is what I do here. And then now what you have to do is that you have to substitute. Okay, let me just check. So now what you have to do, you just have to substitute this number. You substitute 2, you substitute a negative 3, negative 2 and negative 3. So obviously, since we equated the equation to 0, this equation, so when we substitute those roots that we get there, when we substitute negative 2 or negative 3, that equation will actually give us 0. So now that means we must not shade these dots here. So now those are actually not part of the solution. But now what we can do, we can actually substitute the number between negative 3 and negative 2. So what can we substitute here? What's that number? Any number that is between negative 3 and negative 2. Anyone, good people? Which numbers can we substitute there? So we can substitute negative 2.5, right? So that means, for example, we can say now our x, if we let our x to be negative 2.5, so that should be negative 2.5, and then we're gonna square that, and then we're saying now that we have plus 5 multiplied by into negative 2.5, and then we're saying that we have plus 6. Then let's see what we get here. I get a negative 4. What does that mean is that when I substitute any number between those two numbers, I'm gonna get a negative answer. And then now I'm gonna have to substitute a number that is above negative 2, and the number that is above what? That is below negative 3. So these are the sections that I'm talking about. Are we still together, guys? So I'll assume that we all understand so far. So now, when we substitute a number that is below there, let's see what we get. Let's say maybe we substitute in place of x a negative 5 now. Let's say negative 5, and then we change that to -5, which is the number that is less than -3, and then I get a +6. So you don't have to substitute a lot of numbers, so you can just say now here we have what, 6, which is plus, that is +6, right? Yes. So now what else we can do is that we can actually substitute a number that is more than -2. We can substitute for example 0. So if we substitute 0 there, we're just gonna have 0 squared plus 5 multiplied by 0 and then plus 6, which will give us 6. So that is a +6. So that means we'll get positive numbers from this side. So now from there, what we can do, we can now go to our solution to say that now our solution our solution will cover this part, and then maybe let me use a red pen. So it will cover this part, and then it will also go downwards there, and then it will also go up there. So now that means the only parts that don't have solution is -3, -2. So that means now if we want to write this in terms of, let's say, interval notation, can say that x is an element of all real numbers, but x must not be equal to -3 and x must not be equal to -2. So, but mostly the most common way that is used to write the final domain, I'll just write up there, guys. So that means now we'll be having x as an element from -infinite and then to -3, and then from here we can say that we have union, and then from -3 to where, to -2, and then we say union from -2 and then to infinite. So this is our domain. Are there any questions so far? No questions. Okay. Yes. On the top, there's no need, because apparently, if you think about it, any number you substitute on the top will not give you anything that is undefined. I mean, you can substitute 0, you can substitute -1. There's nothing that is gonna be a problem. The only problem is the denominator, because the denominator is a restriction. It must not be 0. So that is why now we only focus on the denominator for this particular problem. Yes. So, but yeah. If you don't put what? I really do not think so, because in your notes they also don't write that. So you can just, even if you don't put that, I don't see a problem. Come again? Yes. That means it's an opposite of what you are saying. When I'm using the curly brackets, that means I'm not including -3. As you can see that in -3, -2, there are only parts that are not included, because if you check my initial solution here at the corner, I said that x is an element of all real numbers, but not 3, and then also it must not be -2. So that means those curly brackets, they mean that we do not include. Yes. So for positive and negative infinite, always we don't include those, because they are not really numbers. So we always put curly brackets for positive and the negative infinite. That's always the case. There's no way whereby we say that the infinite is included. So it will always be like that. Yes. So now I want to do a different problem. So maybe a problem that is a square root. So that you can see how we actually apply these rules. So now let's say, for example, we have this problem here. So now okay, so we have now y is equal to 2 root of x plus 4. So now if you treated that one, we're dealing with what? With a fraction. And then we say that the denominator must not be equal to 0. So now in this case, we have a square root function. We all know that inside a square root function there, we do not need any negative number. I believe that we all know that if we put a negative number there, we'll have what? We'll have something that is undefined. So be careful. We are not saying here it must not be 0. Square root of 0 is defined. It will just give us 0, simple. But we do allow 0 this time around, but we do not want what? We don't want a negative number. So we can say now something that is under the square root, which is x plus, let me write here, x plus 4 must always be greater than or equal to 0. So we can have 0, that's why I put the equal sign, and then but we cannot have numbers that are greater than 0. I mean that are less than 0, which are negative numbers. So you can just say now x must be greater than or equal to negative 4. So now if you go and draw our number line, we have a negative 4 here, and then we have our dot, and then you're saying that x must be what? Must be greater than or equal to negative 4. So that means that we have all the numbers going to the towards positive infinity, because we're saying must be greater. And then also we have now we say that 4 must be included, so we shade that part now to show that our 4 in this time around is included, because if you substitute in place of x a negative 4, you'll get negative 4 plus 4, which will get what? You'll get a 0, and then 0 is allowed. And then if you substitute any number that is greater there, you will still get something that is defined. But once we go below negative 4, let's say we substitute a negative 5 that side, we're gonna have negative 5. So this is what we're gonna have. We're gonna have a negative 5 plus 4, and then that should give us a negative 1 under the square root, so which is undefined, so there will be no solution. So you can always substitute the numbers to confirm. So now that means our domain will actually be x as an element. Now we include 4. We put square brackets from negative 4 to where? To a positive infinity. So you can see my positive infinite again is the curly brackets to show that infinite will always have that kind of brackets, and then 4, since it's included, it will be the square ones. And then I think that one is clear, and unless you guys have questions. So what I want to do, I don't want to waste your time, so I want to do a lot of different types of questions so that you know how to approach different types of questions. So if you guys are clear with that, we can actually proceed. So now one more question here. We have y is equal to x squared, and then we have plus 2x, and then we have plus 3, and then all this is divided by the root of 2x and then minus 1. So now if this is what we have, what are we gonna do? What approach are we gonna use? Anyone? What is the first step that we need to do? Are you guys still around, or you are sleeping now? Eh? Yeah. Why should the numerator not be equal to 0? Um, okay. So guys, when you want to ask a question, don't lift your hand. You can open your mic because at least you guys are able to actually give each other a time to talk. So because I'm not in the meeting currently, I'm in PowerPoint, so I won't see when you raise your hand. Just open your mic and talk because we don't have a lot of people talking at the same time. So no problem. You can just open your mic, you talk, and then we move. Yeah. Exactly. That is the first thing. The denominator must greater than 0. And then when you're talking about the denominator, you're actually talking about the whole denominator. So we're talking about the square root of 2x minus 1. Not only the 2x minus 1, but the whole denominator. We're not allowing any 0 here. So if we're saying x squared plus 2x plus 3 over 0, this will be undefined. So now this must actually be, you're saying must be greater than 0. So we're not even including a equal sign now. So, but the first thing that we can do, we can actually say, because we have two conditions actually here. So I want this to be clear to you guys. So we have this condition and we also have 2x minus 1. So now for the square root function, this one must not be equal to 0. It could be any number. So let's say the all the denominator, the full denominator, we can put a -1 here, it's fine. We can put even -100 here. We can put a +100, we can put 1,000. So we can say any number can go there, but only 0 is restricted. That's the first condition. And when we go to the second one now, under the square root, we know that under the square root we should have a number that is 0. I mean, I want you to understand in which cases should we use not equal to, and then in which cases should we use greater than. So under the square root, we do not want any negative number, but if we're referring to the whole denominator, we can put a negative number. But now, because that 2x plus minus 1 is coming under the square root, we do not need any negative number there. Although for 0 we can include. But remember again, if we include 0 here, that means we're going to have a square root of 0, which is fine, it gives us 0. But once this 0 comes here, it becomes undefined. So because of that, we just say here that should be greater than 0. I don't know if you guys understand. So now let's continue. Now what we're gonna do is just gonna square both sides like that, and then you're gonna say 2x minus 1 must not be 0, and then x must not be equal to 1 over 2. And then this side we can say now x must be greater than 1 over 2. I believe that is clear. We just solve for x. Then now we go to our number line. Always go to the number line. I will always suggest that. So some people don't write number line, and then that thing you get 0 there. So let's say we have our 1 over 2 here, and then we have this here. So that is the only condition that we have. So what about 1 over 2? Can we include 1 over 2? We start by substituting our boundary that we found. So if say 2 multiplied by 1 over 2, I mean we're substituting from that thing under the square root sign there. Minus 1, we're going to get what? This 2 cancels 2, we get 1 minus 1, which is equal to 0. And then the square root of 0 is 0. And then now when we divide by that 0 there, it will become what? Undefined. So if that is the case, that means -2 must not be included. I mean the +2 that we got must not be included. So you can substitute numbers now that are what are below and then above. Let's start by substituting a number that is below 1 over 2. Let's say we're substituting, what is the number? It could be 0. So we could substitute 0 there. So that means we're going to have square root of 2 times 0 minus 1, of which this will actually be square root of -1. Can you see that? Because 2 times 0, that should be 0. 0 minus 1 is giving us -1. And then a negative number under the square root is not allowed. That means we don't have to include these here. And it makes sense because according to this condition, we said that our x must always be greater than a 2. So that side won't have to include anything. So that's restricted. So when we go to the numbers which now are greater than 1 over 2, let's say now we substitute what? We substitute a 5, for example. So we'll be having what? We have 5 multiplied by 2. So minus 1, which would be 5 times 2 is 10. 10 minus 1 is equal to 9. So now when we have 9, we know that the square root of 9 will actually be 3. So we can divide by 3. There's no problem. So we get a positive number. So that means this side is actually defined. So we can write an arrow like that. And then so from here now, we can see that our domain in an interval notation, it will be x is greater than 1 over 2. And then if we actually, no, this is not an interval notation. So you can actually, I think an interval notation is actually the one that would say now x should be the elements from 1 over 2 to what? To infinite. So you can see now that both my 1 over 2 and the infinite, they are not included, because 1 over 2 doesn't satisfy. So when you substitute, another thing that I am suggesting, always substitute to the initial, to the full equation. Substitute the numbers in that full equation. Because sometimes you will be only focusing on below part, only to find out even the above part doesn't accept that 1 over 2. Maybe the below part does accept, but the above one doesn't. So just be careful of that. So are we still together, guys? Are there any questions? Okay, so I believe there are no questions so far. So if there are no questions now, I'm gonna do, let me just check if there are no other people here waiting. Okay, no one. So now let's do one more problem. So now in this problem now it will have restriction on both the numerator and the denominator. So we have x plus 3 here, and then the square root, and then divide by now the square root of what? Of x squared, and then minus 16. So guys, I believe after this problem now I can conclude that we will be able to find the domain of any function. So now, when you're dealing with such a question or a problem, always make sure that you deal with the numerator, you deal with the denominator one by one. So here, we know that in the numerator, we can actually accept 0 because the square root of 0 is 0. So if we divide, we say 0 divided by 2, it will actually give us 0. So there's no problem. I'm just making an example. Obviously, this is x squared minus 16. So from here, we can actually say now x plus 3 is what? Must be greater than or equal to 0. Am I correct there? Because why we're using that condition is because we have a square root function. Under the square root, we do not need anything that is less than 0. But we can accept a 0 there. But it must not be less than 0. So now we're going to have our x which is greater than or equal to negative 3. So that is the first condition there. So from here, we're going to the denominator. When we go into the denominator, all the denominator, the full denominator, which is x squared minus 16, must actually not be equal to 0 because a division by 0 is undefined. And then now we're gonna square both sides like that, and then we're gonna get now x squared minus 16 must not be equal to 0, and then x squared must not be equal to 16. Are we still together, guys? Or some are sleeping? So now from here, if we put the square root both sides, remember guys, when you put the square root, you'll get plus or minus. So from here, that means we have x must not be equal to plus or minus 4. Or else you can factorize. Alternatively, you could say x squared minus 16 must not be equal to 0. And then to say that is x and x. This is a difference of two squares. and then that should be plus 4 and minus 4, and then you get your answers. So you get the same answers. So from here now, what can we do? We go to the last condition now, which is the square root under the in the denominator. Remember, the square root we dealt it what there was the one below, and then we dealt with the full denominator. Now we're gonna deal with the square root function. Now we know that our x squared minus 16 must always be what? Greater than or equal to 0. But remember again, as we said in the previous examples, that even if the square root below here can accept 0, but because that 0 will also divide the whole function, now we don't include 0 because of that. I believe you guys, I make sense. So that means now we have x squared, which must be greater than 16. So here, after this, we don't really have to put the square root both sides since we have an inequality. We can actually take this as critical values, which is x is equal to 4 or x is equal to negative 4. But either way, you can see that these values already, we have them in that second condition there. So the only thing that we can just go to now is the number line that will confirm everything that we've done. So now we have what? We have negative 4 and then we have 4. Those are the two things that we have. And then now, if we substitute a negative 4 there under the square root, we'll have a negative 4 and then negative 4 squared. Or we also have a negative 3. Sorry for that, guys. Remember this first condition we dealt with. We also have a negative 3 here. Do you guys have any questions so far? Can you say that again? Yes, the condition, this condition that is from the one I highlighted in green. Is that what you mean? Exactly, yes, we put both of them. We put both the conditions for the numerator and the denominator. Come again? Ash, your network, I can't hear you clearly. Anyone who has a good network who can interpret for me. Yes, we do. Yes, that is also true. Because remember that if we erase the square root, then we have x plus 3. Obviously, we don't have a restriction. So, I mean, there's no restriction we can do. I mean, if we didn't have a square root, we wouldn't even do this. So, because now we have a square root, so obviously we have to include it because we have a square root. So let's say, for example, you just have x plus 3. It's more like when you have y is equal to x plus 3. I mean, this the domain for this will actually be the element of all real numbers. So it will just be x as an element of all real numbers, or from negative infinite to positive infinite. So hence we wouldn't even focus on it. But already we did this condition, so we have to include it. I believe that I've answered the question. So from here, we substitute all these numbers. Let's say now we substitute a negative 3. So obviously, we substitute into the whole function there. But if you check, already above, negative 3 will be accepted because we're just going to get 0. But what if we substitute below? So if we substitute below, we're going to have negative 3 squared minus 16. and then 3 squared is 9. So 9 minus 16, we're gonna get what? A negative number, right? So if we get a negative number, that negative number under the square root will not be allowed. So we cannot include negative 3. So negative 3 here cannot be included. So I believe you guys can also see the advantage of actually substituting into the full equation, the equation we were given. Because you see, that's what I was explaining, that negative 3 in the numerator is accepted. But when you go to the denominator now, is not accepted. So I believe that makes sense. So now we go to negative 4. So check something again. When we substitute to the full function again, in the numerator we will have negative 4 plus 3, which will be equal to the square root of negative 1, undefined. But if you could go to the denominator, you will be having negative 4 squared minus 16, which will be 0, and then the square root of 0 is actually 0. But because the numerator doesn't accept this, so we just not gonna be able to include negative 4. And then with positive 4 is still the same thing, because we're gonna have in the denominator, so if you check the positive 4, we're gonna have the square root of 4 plus 3, which is accepted in the numerator this time around. But now when we come to the denominator, we'll be having 4 squared minus 16, and 4 squared is 16, so that means we're actually having a 16 minus 16, which give us a what? Which give us a 0. So division by 0 is undefined. Now negative 4 was not accepted in the numerator, but it was accepted in the denominator. But now the positive 4 is not accepted in the denominator. So that's why now that is the importance of substituting into the initial equation. So all these numbers are actually not accepted. So what else we can do? We can substitute numbers between negative 4 and negative 3. So I believe that could be negative 3.5, for example. To find that number easily, if you are not sure, you can just say 4 plus 3 and then you divide that by 2. You'll get 3.5. So you can substitute negative 3.5 there. So to that full equation. So if obviously already in the numerator, if we substitute negative 3.5 plus 3, we're going to get a square root of negative 0.5, of which that means we do not have any number here between negative 4 and negative 3. And then if we substitute a number that is below negative 4, let's say negative 5, obviously again in the numerator, we're going to have negative 5 plus 3, which will give us square root of negative 1, and then that is undefined. So you also don't have a number here. So now we go between negative 3 and 4. We can substitute a 0 there. 0 is between negative 3 and 4. So if we substitute there, we're going to have 0 plus 3 in the numerator, which is accepted, and then the denominator of 0 minus 16. And then 0 minus 16 is actually negative 16, so that will not be accepted. So we also do not have any number here. So now the only option we have now is to go above 4. Let's go above 4 now and substitute 5. So square root of 5 plus 3 will give us a positive number. Divide by square root of 5 squared will be 25 minus 16, which will also give us a positive number. So now that means we'll get a solution here. So that will only mean that now this thing will be actually x as an element from 4 to actually positive infinity. So is there any question? I think guys, I try to explain this by all that I can. So this is how you deal with the domains, unless there's any question. So if you listened very well and then you see that you understood what I said, you'll always get this correct, because it's either you have only one restriction in the numerator or in the denominator only, or both numerator and denominator. And you have to know also that if you have a square root function, under the square root we do not need any negative number, so that thing under the square root must always be greater than 0 or equal to 0. But obviously if that square root function is below the denominator, so it could not be equal to 0 also, whatever, etc, etc. So I tried guys, unless you have questions. So now I'm going to another thing. So unless you have a specific question that you want us to do or so, but for me on my side, that's all that I can say. If you know this information, then you won't struggle with anything. You really won't struggle with anything. So what I meant when I was saying the composite function, I won't stick much. Let's say you are given f of x is equal to x, and then you are given g of x is equal to x squared plus 1. No, let's say root x there. So you want the domain of a composite function. Let's say you want the domain. They are saying maybe the first question, find the composite function. So now to find the composite function, you know that let's say the composite function can be two. There is either you find g of f of x, or you find what? You find f of g of x. So and some people, they do not know composite functions. So a composite function, you will be given it like this. They would say find number a, they would say find f, they do this, and then they say g of x. Number b, maybe they would say g and then f of x. So some people, they do not know how to separate a multiplication from a composite function. Guys, this thing means that we're taking g and then we're substituting this g inside f. And then this one means that we take f and we're substituting the f inside g. That's what it means. But when you are given something like this, is it different when you are given something like this, f dot g of x. Now what does this mean? It's a very different thing. You can see there is really a dot there. So this one means that we have f of x multiplied by g of x. That's what it means. Very different from that one. So if you have g dot f, that means you have what? G of x multiplied by f of x. So that's how we do x. So some people, when they are given composite function like this, they do a multiplication. So that is wrong. You will get 0 obviously. So now for here, if you are to find f, let's just deal with the, maybe it's fine, let's find both composite functions. If we were to find f of g of x, now we know that we're gonna be substituting what? G inside f, like that. So that means our f is actually the square root of x, and then in place of x we're substituting what? G of x. That's what it means. So remember, we had the square root of x and then as f of x. So inside that f of x, in place of x, we put this function g of x. So that means we're going to have the square root here of what? Of x squared plus 1. That's what it means by composite function. And then when you go to the second one, now we have g, and then we substitute inside g f of x, like that. And then that means we're going to put our g of x, and then our g of x is actually x squared plus 1. But inside x, that's where we put what? Our f of x squared, like that. And then this will give us our f of x is root x and then squared plus 1. You had this question in your in one of your tasks, and then 90% of people didn't get that correct. So yeah, so but let's see, people were able to do this, and then after doing this, they simplified, they say x, because square root of x squared will be x and then plus 1. So this is what you got. And then from here, now we want what? The domain for composite function of a. Let's say the domain. Now we want the domain, and then b, we want the domain again for the composite function of number b. So now what are we gonna do? For a, you can see that you have a square root of x squared plus 1, and then under the square root we don't want what? We don't want a negative number. That means we're saying that now x squared plus 1 must always be greater than 0. That's the only condition that we have. Or in fact greater than or equal to 0, because we can have 0. And then now we can say now that our x squared should always be greater than or equal to -1. Anyways, when we put a square root both sides there, we'll get something undefined. So either way, any number that we put, what does that mean now? It means that any number that we put inside x squared will always be positive, because we can put -1 squared plus 1. -1 squared is positive. We can put 0, any number. So the reality is that for the first composite function, your domain will be x as an element of all real numbers. Or maybe we can write it like this: from -infinity to +infinity. Are we still together, guys? Guys, are you still there, or I'm alone now? Yeah, so I'm trying to explain this by all means so that you don't make any mistake. So now, as you can see, any number that you substitute for x squared honestly will not give you anything undefined. It's just like when you have, because of that square. Otherwise, if we had just x plus 1, when you substitute a -5, obviously, we'll be having -5 plus 1, which will give us a -4. So that will be undefined. But as long as squared here, even a 0 will give us a solution, because we'll be having 0 plus 1, which will be square root of 1. So that is the domain for the first one. And then now we can go to the second one. Second one, people did same mistake for both tutorials. So must listen me very attentively, because it's highly possible that you're gonna get the composite function and then they'll ask you to actually find the domain of a composite function. That one is just highly possible. It was there in your first tutorial, it was there in your second tutorial test. So now, to find that domain for the second composite function, remember that we're saying that now our second composite function is this one. But we do not use this simplified version. To do the simplification is fine. So the way it was marked, you actually have, let me do like this. So you're actually having a mark for doing this, you're having a mark for substitution, you're having a mark for this. And then the final fourth mark now is for the domain. So the domain, you do not use this, you do not use this. But what you use that initial one you didn't simplify. And if you use that one, you can already see that we'll be having what? We'll be having, and I think one of of you guys told me that you were told this thing. So, but most of people, 90% didn't get it correct. So very few people got it. So the restriction there will actually be the square root. Under the square root, you want greater than or equal to 0. So that means now our domain will be x as an element from 0. We should be included from 0 to a +infinity. Any question, guys? I know that now you are getting confused, but then that's what you must do. That's what we're supposed to do. So after you're done with this one, now you'll get your fourth mark like that. So people didn't get this mark. I'm saying in B, let me check how much time do I have. So guys, since I'm using a Zoom, so Zoom meeting is nice because it's simple to use and then it's simple to draw and everything is just simple. So, I mean, not Zoom actually, Google Meet. This is Google Meet. So, since I'm using this, I only have 1 hour. So after 1 hour, it will actually kick me out. So I'll send another link. I'll create another link that will give me 1 hour again until we finish at our 9:30. So now I can just explain in this 5 minutes, but I'm saying that so that you know when it kicks us out, you know that we are actually having a problem. We will join in the next one, in the next link that I will send in the groups. So now what I'm saying in number B, you do not use the simplified version, which is x plus 1, because people use this simplified version. And then obviously if you take a domain there, it will be x as an element of all real numbers, in a way that you will have something like this. So your domain would actually be negative infinite to positive infinite if you were to use that x plus 1 for that composite function of p. But now instead you have to use what? You have to use this one that is not simplified here. So you have to use this one here, square root of x. So you need to look at square root of x alone. So that's what you must do. So under the square root of x, you know that you must not have anything less than 0. Hence I wrote the x must be greater than or equal to 0. And then if you did that, obviously your domain now will be x as an element from 0 to positive infinite, because you can substitute 0 there. 0 plus 1 will be 0, but you cannot substitute what? A negative number under that square root. So that's what I meant. Do you understand now? Yeah, so please always when you deal with composite function, check very properly that you use the first equation there, the first equation that you have without simplification. So that's all I mean. So that's it. So yeah, I think guys, I'll just have to create a new meeting because this is gonna kick us out, and then after that now we can approach a different thing. So if you actually understood what I said with regard to the domains, and then also the domains of a composite function that you must not simplify, at least you'll know now that how you should do it. So let me see what time, how long now do I have? Ends in 3 minutes, so I can do something. So some people also they were not able to interpret these things. You guys you are not able to interpret these things. Let's say you are given, when you are given f plus, so when you are given f plus g of 2, and then maybe let's say when you are given f multiplied by g of 2, maybe let's say you are given h over g of 1, and then let's say you are given f minus g of negative 1. So when you are given this, that means you're gonna have to substitute 2. That means you're gonna have something like this, just like you're gonna have f of 2 plus g of 2. So if our f of 2, for example, our f of x was equal to x squared, and then our g of x was equal to x, that means you will be having you'll be having f of 2 multiplied by g of 2. I mean plus for the first case. So in f you substitute 2, you have 2 squared, plus in g you substitute 2, and then you'll be having 2 squared is 4, and then this should give us 6. That's how you solve that. So again, when you are having a multiplication, you just substitute. You just say now you'll be having f of 2 multiplied by g of 2 for the second one here. And then for this one, third one, we'll have h of 1 divided by g of 1. That means you have 1 squared if you substitute in x squared, and then in x you have 1. So something like that. And then for this one, f minus g of negative 1, you're actually having what? F of negative 1 minus g of negative 1. So inside f you substitute, you get an answer. Let's say after substitute that negative 1, you get 5 minus, you substitute in the function of g of x. Let's say you get what? You get 2. You subtract those, you get 3. So those are what that's what is happening there. So I'll pass that also unless you have questions. So that's how you do that.